So I called this lesson Advanced Inclines. Really what we're talking about here is what can I do with inclined planes and ramps. Should appear in about this mass up the frictionless ramp at a constant speed. You know what? There's a two-word... Guys with me? Okay. There's a two-word key phrase here. What's the key phrase here? Constant speed, which means what? Which means A is 0, which means my net force is 0, which means everything is balanced, which means winner equals loser. It means all of those things, and I'll decide which of those will be most convenient. They already gave me a picture. That was nice of them. So how am I going to start out? Really?
Gravity.
Pardon me?
Draw gravity.
Even before that, what do we call this process? Huh? Free body diagram. Okay. Let's do a free body diagram. Although, let's label the forces on our picture since they gave me such a lovely picture. What are the forces acting on this now, Connor? Get the obvious one. Okay. Always put the mg on the pointy side. And now we're saying on inclined planes, pause. Break gravity up into its perpendicular and parallel components. Also, if that angle is 40 degrees, this angle is 40 degrees. And now I can do my trig. I'll stick the lovely right angle right there. What else? Normal force. Like that? No. It's going to be at right angles to the surface. How big? Looks like it's going to be about that big-ish. What else in this question? This is a little bit different. We haven't done one quite like this before. Yeah. Tension, because there's rope. Okay. Is there friction? Okay. What's my equation? Now, normally I say, who's winning and all that, but let's see if we can just do it all in one fell swoop. What's my equation here? Perpendicularly, my forces are balanced. Normal force equals mg perpendicular. What about parallelly? If that's a word. What about in the parallel direction? What could you write as an equation? Okay, let's go a bit longer then. Which way is this thing moving? Up the ramp? So let's assume up the ramp is winner. Who's winning? More specific, which force is winning? Are there any other forces up the ramp? So who's losing? Down the ramp. Who's losing? mg parallel, so minus mg parallel. Don't write this next bit down, just watch. What does winner minus loser always equal? MA. What's A in this case?
0.
So don't write this down. Don't write this down. You're telling me that's the case? Don't write that down. What would you do with that mg? Plus it over? And you would get tension equals mg? Okay. Write that down. See how clever that was? Huh? Hey? Huh? Hey? Parallel. Not mg. mg parallel. Okay. Oh, we're nearly done. mg parallel, which trig function? How do you know? What's a dumb way to remember? 2 lines, a sine? Okay. Again, you can always derive it. If you forget, mg is hypotenuse, mg parallel is opposite. It is sine. So we can say this is going to be mg sine theta. Does the m cancel in this one? No. And it shouldn't. It seems to me it would be tougher to pull a larger mass up a hill at a constant speed. It shouldn't cancel here. So tension is going to be 7 times 9.8 sine 40. What do we get? Seven times 9.8 sine 40. 44.1 newtons. I gotta be honest, that's a C, maybe barely a C plus level question, because you'll notice really 2 lines and we were done. Let's add some friction. So B says, suppose mu is 0.65. How much force is required now? You know what? Let's do a quick redrawing here. So there's the ramp. There's the block. What was theta? 40 degrees. What are the forces acting on this? Get the obvious one. So we have mg down. We're going to break it up into mg perpendicular and mg parallel. What else was there in our free body diagram? Normal force. Looking like that. What else was there? Tension. What else? Now there's friction. Which way? We have to figure out which way is this block sliding or wanting to slide. Which way is this block sliding according to this question? Up the ramp. So which way will friction be pointing? Down the ramp. By the way, what if instead of up the ramp, what if the block was sliding down the ramp? Because maybe we were lowering it down via the rope. Which way would friction be pointing? Up the ramp. Depends which way this block wants to slide. That was very similar to the last question from your homework last day, which asked you for a minimum force and a maximum force. Really what we were saying is, do you want it to be sliding up the ramp or do you want it to be sliding down the ramp? In this case, we know it's sliding up the ramp, so friction is going to go like that. Can anybody give me my new equation from here? Yep. It's winner minus loser, but Bryce, winner minus loser equals 0. So really you can say all the winners equal all the losers. We'll call up the ramp the winner, because it's moving up the ramp, T, and anything down the ramp will be the losers. There's 2 of them this time, friction and mg parallel. Then we would say to ourselves, this hasn't changed from physics 11, friction is what times what? Mu times the normal force. Okay, so we would go mu normal force plus mg parallel. I don't know the normal force, but look. Got another force the same size as the normal force, and it's not mg. Which one? Mg perpendicular, so I'm going to get tension is mu mg perpendicular plus mg parallel. Do the m's cancel here? Is there an m in everything? Henry, is there an M right there? Say yes. Is there an M right there? Say yes. Is there an M right there? M's don't cancel. So common mistake, I see kids cancel the M's here because it's in everything on one side. It's got to be in everything everywhere. Perpendicular. Which trig function was that one? Oh, of course it was. Okay, here we go. So tension is going to be mu mg cos theta and mu mg, sorry, not mu, and mg sine theta. I guess that's our general expression for tension if you're sliding an object up a ramp with friction slowing it down. Mu is pretty big, 0.65, so tension should be fairly high. What was the mass? 7? 9.8 cos 40 plus 7, 9.8 sine 40. 0.65 times 7 times 9.8 cos 40 plus 7 times 9.8 sine 40. That looks right. Yeah, 78.3. There you go. Okay. And if you were lowering this down the ramp so that friction was pointing up the ramp, friction would have ended up next to tension, and it would have been, then you would have minused it over. Tension is way smaller, which kind of makes sense because friction is doing some of the slowing down of the mass for you. Tension only has to overcome what's left. Next one. Two objects are connected as shown. Mass 1 is 12, and it sits on a horizontal surface that has a coefficient of friction of 0.17. Mass 2 is 9.8 kilograms, and it sits on a frictionless surface. So here, don't write that down, but I guess mu is 0, or maybe it's on wheels or something like that. Find the acceleration. Well, this is a job for free body diagram. What are the forces acting on mass 1? Get the obvious one. I agree. Is there more than one mass, Bryce? I'll call it M1G. What else? Normal force number 1 to go with mass number 1. What else? Which way? Good. What else? Friction. Which way? Now I got to think. Which way is this mass going to slide? Is there any way that an inanimate object on its own would suddenly start crawling to the left, pulling this object up a hill? So it's either going to be at rest, maybe friction is so big that nothing is moving, or it's sliding to the right, which means friction is pointing which way? Yeah. And I'll call it friction 1 to go with mass 1. What are the forces acting on mass 2? Get the obvious one. M2G. Pause. Now we're on an incline. Now, Seb, I'm going to carefully break gravity up into its components. You're back with us because you were zoning out there. Mg perpendicular. Mg parallel. What else? Josh has got to be a normal force. Are we sinking into the ramp like quicksand? Are we flying into the ramp like off the ramp like Superman? So normal force is going to be, in this case, the same size as mg per... Oh, wait a minute. You know what, Mr. Dewick? There's two masses, m2g and m2g. I should have put 2's there, shouldn't I? And normal force number 2 to go with mass number 2. What else? Okay. Who's winning? If this thing is accelerating, which way must it be accelerating if it is? Up and left or down and right? Down and right. So which force is down and right? Which is causing all this to happen? Which is our winner? I think M2G parallel. So now I'm going to write an equation for all of the forces, Connor, along the rope. And anything that ends up pointing down the ramp to the right will be winner plus. Anything that ends up pointing up the ramp when it gets to there is going to be a loser minus. So, who's winning? M2G parallel. And now let's walk along the rope. My good old friends, minus tension and plus tension. What else? Minus or plus? Minus friction force number 1. There's all of the forces along the ramp. Sorry, along the rope. Along the rope. What's that going to equal? I got to be fussy, not MA. M all A, because we got forces from more than one mass, right? Bryce, do we get to relax a little bit? Yes, we do. Okay. This is going to be M2G parallel minus mu normal force number 1 equals M all times A. And I need to move over here. I'm running out of room, it looks like. I left too much room for the tension and not enough room for the acceleration. I'll have to fix that. This is going to be M2G parallel minus mu, I don't know, normal force number 1. Oh, but look. Another force the same size as normal force number 1. What? M1G. That equals M all times A. Do the masses cancel here? Well, M all is M1 plus M2 in brackets. Is there an M1 plus M2 in brackets in the other masses? So here, masses don't cancel because you got two different masses. Okay, so the acceleration is going to be M2G parallel. Two lines. Parallel. Two lines. Sine. Minus mu M1G all over M1 plus M2. Let's get the answer. Mass 2, I've scrolled down here. What was mass 2? It was 9.8, 12, and 0.17. So 9.8 times 9.8 sine 42 minus 0.17 12 9.8 all divided by 12 plus 9.8. I'm going to be really clever since it's 9.8 times 9.8. I'm just going to hit my squared button because I can there by a fluke. Sine 42 minus 0.17 times 12 times 9.8. Close off the top. Divided by bracket 12 plus 9.8. Oh, 12 plus 9.8. 9.8 times 9.8 sine 42. I'm missing a plus sign, or minus sign. Goes right there. Insert minus. 0.17 times 12 times 9.8. That's totally wrong. I put a negative sign there. I did what I've yelled at you about. You get 2.03? Are you ready for my worst joke of all time? I only came up with it last year. It took me 19 years to make this up. So here it comes. Taylor, what does B want me to find? Why can't I use this equation to find tension? What happens to the tensions in this equation? Are you saying we have a tension deficit disorder? Huh? Eh? Huh? We're missing tension, so we have a tension deficit. And we need it, so it's a I know. I made it up last year. I introduced it to you guys last year, but I got to bring it back to my new students. Nothing. Really, nothing. Wow. How can I find tension? Here, really, both of these masses are kind of uglyish. I would probably use mass 1 to find tension. So let's write an equation for mass 1. Who's winning for mass 1? Tension. Who's losing? And that's going to equal M1A. Tension is going to be M1A plus friction. It's going to be M1A plus mu times the normal force. I don't know the normal force. Oh, but look. Another force, same size as the normal force. I think M1G. And now I can plug in numbers. Mass 1, was it 12? No, yes? 2.03. I'll use my answer button there. Plus 0.17. 12. 9.8. 12 times answer button plus 0.17 times 12 times 9.8. 44.4. And it's a force newtons. I'm going to go back a couple of lines here. On my calculator, this is the acceleration equation. What if friction was so big that this couldn't move? In other words, what if mu was so large that friction was so large that nothing happened? I'm just going to go, and instead of a mu of 0.17, suppose mu had been 0.87, and this thing isn't moving. How would I recognize that when I tried to solve? Look, watch my calculator. How would I recognize that when I tried to find the acceleration? What's your hint that you've got the wrong winner? Yeah. It'll catch your eye. I've taught you, hopefully, to stare at your calculator and not trust the numbers, analyze them. It'll catch your eye. If you ever get a negative acceleration, you picked the wrong winner. In this case, it would mean nothing was moving. If you knew it was moving, whoops, it's not going up, it's going down, or whatever. Kind of like, something like this. Example 2 says, how would you determine the direction that this system moves? We have a little m, we have a big M, we have a theta. Okay. You see, don't write this down, but I'll put some numbers on here. If this is 5 kilograms and this is 7 kilograms, I know this mass is heavier, but depending on how steep this angle was, this might still be able to pull it up the hill. Now, if theta was 89 degrees, so that it was nearly vertical, I know the 7 would be winning. But if theta was 48 degrees, now I'm not so sure. How can we figure it out? Devin, you know what this is a job for? What are the forces acting on little m, Devin? Get the obvious one. I'll call it M1G. Tension. What are the forces acting on big M? Get the obvious one. I'll call it big MG, since they went with big M. Components. Big MG perpendicular. Big MG parallel. Yes, there's also a normal force and tension and friction if there was. Which two forces are having the tug of war in the same direction as the rope in our free body diagram? Can you see it? Which ones are pulling at each other? Josh, you're nodding. Which ones? Parallel. Okay. So how would you would compare little mg to big MG parallel? How would you quickly calculate big MG parallel? Well, parallel is two lines is boom, boom on your calculator. Quickly go little mg. I'll be honest, I don't bother doing that. You can. Emily, often I'll just make an educated guess. And if I've guessed wrong, do you know how I'll notice it? Negative acceleration. But here's a nice thing. Because my calculator lets me backspace and edit, it's almost always a really quick fix. I just change any winners to losers, any losers to winners by just moving the plus signs and minus signs around, and I can get the right answer. And actually, I found that's usually quicker guessing than me calculating both these ahead of time. So you can absolutely do this. But just to show you, we're going to do example 3 wrong. So here's example 3. What are the forces acting on it? Devin, go again. Get the obvious one. More than one mass. Now I'll call it M1G and tension. What else? I think that's it on mass 1, yeah? What are the forces on mass 2? Get the obvious one. So we have M2G. Pause, componentize it. M2G perpendicular. M2G parallel. 90 goes there. That's the 30. That's the 30. Devin, what else? Are we thinking normal force? Good. I'll call it normal force number 2 to go with mass number 2. Even though there isn't another normal force, it's just easy to keep track. What else? Is there a rope? Tension. Is there friction? How do you know? Is there a mu? Yeah, so is there friction? How do you know? I gave you a coefficient of friction. Not much friction. Which way? This is the problem. I don't know whether the 8 is sliding up or sliding down. You could crunch the numbers really quickly. You could go, okay, M1G is 5 times 9.8. M2G parallel is 8 times 9.8 sine 30. Which one is winning, the 49 or the 39.2? I'm going to guess wrong on purpose, just to show you it's not the end of the world. So I'm going to pretend that mass 2, the 8, is sliding down the hill, even though it is sliding up the hill. I'm going to guess wrong. So if it's sliding down the hill, which way would I point friction? Okay. We would go like this. Who's winning? We would say M2G parallel. And now we write an equation along the rope. Who's losing? It looks like I have a minus tension and a minus friction. And then a plus tension and a minus M1G. That's going to equal... Am I right? Did I miss something? Oh. You were looking befuddled at me and I thought I'd missed something. And it's going to be M all A. Tangents cancel. We're going to find the tension a bit later on, but I'm just going to scribble that because I need more room. I need to reformat the spacing on this. How would I get the A by itself, Dev? Okay, so we're going to get this. A equals M2G parallel, two lines. Two lines is sine theta plus friction. Friction is mu times normal force number 2. That's what you were puzzling at, and that's what I should have done. Yes, you're right. It's minus. Thank you. That's going to go on YouTube. Whoops. And then minus M1G. All over M1 plus M2. By the way, Devin, I don't know the normal force. Oh, but look. Another normal force, same size as the normal force. And don't say M2G because it's not. Which one is the same size as the normal force? M2G perpendicular. Good. So we're going to go like this. A equals M2G sine theta minus mu M2G cos theta. You said perpendicular or cos, you did? Yes? Minus M1G all over M1 plus M2. Now again, we picked the wrong winner here, but just to show you it's not the end of the world. Bryce, do you have a headphone in your ear? If you do, could you take that out, please? Thank you. I've scrolled way down. What was mass 2? Somebody, what was mass 2? Thank you. 8 times 9.8 sine, what was theta? 30. Minus mu, was it 0.05? What was mass 1? 5. 9.8. No, sorry, what was mass 2, not mass 1. Good gosh, Duick. 8, 9.8 cos theta minus, now what was mass 1? 5 times 9.8 all over 5 plus 8. And if I carefully, by the way, this is what you want to practice typing into your calculator, because if you can't type these in and get the right answer, it does you no good on the test to have all the right work if you can't actually crunch this. So this is the level of difficulty you want to get very comfy with. Is this a fraction? Yeah. More than one thing on the top? Yeah. So I got to put brackets around the top. Those of you with the fancier Casios with the orange buttons can use the fancy fraction button. For me, it's going to be 8 times 9.8 sine 30, close off the sine, minus 0.05 times 8 times 9.8 cos 30, minus 5 times 9.8 divided by, can I add 5 plus 8 in my head? How do I know I've guessed wrong? All right. Oh! Easy fix. You get negative 1.01 something? Yes? All right. So who is actually winning? M1G. Which way is block 2, the 8 kilogram mass, sliding actually? Up the ramp. Which way is friction pointing? So here's my corrections. I'll do them in, oh heck, green. Scribble, scribble, scribble. Friction. Who's winning? Which force is winning? M1G. Look. Put a plus sign there. Put a plus sign there. Put a plus sign there. Put a plus sign in front of all of your M1Gs. Do tensions still cancel? M2G parallel, winner or loser? Loser. Put a minus sign there. 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 What about friction? Winner or loser? Sorry? Which way is friction pointing? Down the ramp? Which way is the winning direction? We've said it's moving up the ramp. Right? We've said this guy's the winner now. Right? Because we guessed wrong. So this is winner. So which way is friction? Winner or loser? Loser. So friction should be negative. Holy smokes, it already is. 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 So if I have a good calculator and I can backspace, what do I really need to change? It looks like all I need to do is put a negative there and put a positive there. So, Pauline, if you guess wrong, it's not the end of the world. It's an easy fix. How will you know you've guessed wrong? And this is really what I want you to realize. Your acceleration will be negative. You guessed wrong. I guess we're accelerating up the ramp at 0.4927. Is that right? Okay. A equals 0.493 meters per second squared. And now I can find tension. Which mass would I use to find tension? Oh, you cleared it. Oh! Have I taught you nothing? You never clear things. Which mass, Alec, would be way easier to use to find tension? The 5. What's the equation for the 5? Which way is the 5 accelerating? Down or up? Down. Now we know it's accelerating down. So what's my equation for tension? Equals M1A. Do the swappy dance. We're going to get tension equals M1G plus, no, not plus, Mr. Dewick, minus M1A. M1, 5 times 9.8 minus 5 times answer button. And it looks like the tension is 46.5. Now, I'll be honest, Connor, depending on how tough the question is, I will sometimes pre-crunch the numbers and do the comparison and see which way it's going to be accelerating. Sometimes if I'm in a real rush, I'll make an educated guess because usually my guess is right because I kind of think about it. But if I'm wrong, it's an easy fix. Is example 4 the last one? Yes, it is. This is the level of a good A-level question. Huh? This is a nice question. Good challenge. Why is this question tougher than the ones we've been doing already? What did not they give me? What are they asking me to find? A mass. Hey, wait a minute. We did this the other day. We said our strategy, we just reverse everything. When they give me both masses, we write an equation for everything and then go look at individual mass and individual equations. If they don't give me both masses, I'll go look at the individual mass that they did give me, write an equation for it. It'll either help me find tension or acceleration, and then move that to the mass that they didn't give me. Oh, and then I pulled out that little Math 9 clever argument. Cool. So, mass 1 has a mass of 8 kilograms. And it's accelerating upwards, so I know that A is that direction, which now tells me who's winning. I gotta be fussy. Which force part of M2? I think M2G parallel, right? That one. Okay? What are the forces acting on mass 1? Get the obvious one. What else? Tension. What are the forces acting on mass 2? M2G. There's theta. Break M2G into its components. M2G perpendicular. M2G parallel. There's theta. What else? There's going to be normal force number 2. There is going to be tension. Is there friction in this question? Okay. Which way is mass 2 sliding according to this question? Down the ramp, so which way is friction going to be pointing? Up the ramp, because friction resists sliding. Friction force 2 to go with mass 2. So normally I'd say who's winning, we'd write an equation for everything, but we don't know mass 2, that won't do us any good. Which mass do we know? What's an equation for mass 1? Which way is mass 1 accelerating? So who's winning for mass 1? Who's losing? More specific, which one? Good. Equals. What can this help us find? I think this can help us find the tension, which is what part A wanted us to. So, oh, cool. Okay. Tension is going to be M1A plus M1G. It's going to be 8. They had to have told, yeah, they told me 8. 2.1 plus 8, 9.8. You get 95.2. Newtons. What does B want me to find? B wants me to find mass 2. Brisa, which way is mass 2 accelerating? Up the ramp or down the ramp? Who's winning? Good. So what's the equation? It's going to be M2G parallel. And then I guess minus tension minus friction force 2 equals M2A. Friction is what times what? Mu times the normal force, so times normal force number 2. So it's going to be M2G parallel minus tension minus mu normal force number 2 equals M2A. I don't know normal force number 2. Oh, but look. I know another force same size as normal force number 2. Which? M2G perpendicular? Cool. So it's going to be M2G parallel minus tension minus mu M2G perpendicular equals M2A. Let's do our trig. Parallel, 2 lines. Which trig function? Sine? M2G sine theta minus tension minus mu M2G perpendicular. Which trig function? Of course it is. Equals M2A. What am I trying to find? M2. How many M2s do I have? Lots of them. Let's get them all to the same side. I think the easiest way here, Mackenzie, would be plus the tension over minus the M2A over. That's going to give me M2 G sine minus mu M2 G cos minus M2A. That equals tension. How many M2s do I have? 3. How many would I prefer, Josh? You know, it'd be really cool. It would be cool if it was a Math 9 operation that I could pull out of my back pocket and somehow change this from 3 M2s into 1 M2. And there is. Which one? I can factor this, really? So it's going to be M2 bracket, and then there's going to be a G sine theta minus mu G cos theta minus A. That equals the tension. I have to do this up here now. How would I get the M2 by itself? It's going to be the tension all divided by G sine theta minus mu G cos theta minus A. What was the tension? 95.2. G, 9.8. What's theta? 28. Minus, hey, what's mu? I don't know. What's mu with you? Mu was 0.12 times 9.8 cos 28 minus 2.1. Whew! Do you see what I meant when I said, Josh, I don't know if these equations are harder as much as they're longer. I got to be more careful. There's way more room to make mistakes. But I don't think I've taught you anything new today. (9.8) sine 28 minus 0.12 times 9.8 cos 28. Hang on, Mr. Duke. Let's do this properly. 95.2 divided by bracket 9.8 sine 28 minus 0.12 times 9.8 9.8 cos 28 minus 2.1. Do you get mass 2 being 65.1 kilograms? There you go. Advanced inclines. There is absolutely on your test going to be a question that has an Atwood machine combined with a ramp. In other words, something an awful lot like this picture. I don't know if I'm going to ask you to find a mass, but I'm absolutely going to be asking you to find acceleration and tension and things like that. Questions that you can handle now. You can try number 1. Number 2. Whew. Number 4. Number 5, all of you right now on number 5, you might want to take that 120 and break it up into perpendicular and parallel. Since it's an applied force, you can call it F applied perpendicular and F applied parallel. And you're going to find you get a different normal force. I'm not going to ask you to find an angle theta. 7 is good. 8 is good. Skip 9. Ten is good. Skip 11. 12 is good. 13. That's a lot, I know.